As the clock ticks against climate change, the urgency for sustainable solutions has never been more critical. Our planet's resources are dwindling as consumption rates soar, threatening biodiversity and human livelihoods alike. It's in this context that artificial intelligence, or AI, emerges as a beacon of hope, a tool potent enough to possibly reverse or at least mitigate some of the damage we've inflicted on our environment. AI provides a unique opportunity to enhance sustainability across various sectors by enabling smarter resource management and reducing waste. By integrating AI into our daily practices and industries, we have the potential to not only protect but also restore the environment. This technology can drive efficiency in energy consumption, streamline manufacturing processes, and optimize agricultural output, all of which are essential for sustainable development. The promise of AI in advancing sustainability is immense, yet it requires careful implementation to ensure that the benefits are widespread and equitable. As we delve deeper into how AI is revolutionizing sustainability, it's essential to keep in mind that technology alone isn't the solution. It must be part of a broader, integrated approach to truly make a difference. AI's role in transforming the energy sector is pivotal. By utilizing smart algorithms, AI can optimize energy consumption in real time across various systems and infrastructures. This not only reduces unnecessary power usage, but also helps in significantly lowering greenhouse gas emissions. For instance, Google has employed AI to enhance the efficiency of its data centers' cooling systems, resulting in a 40% reduction in energy consumption. Furthermore, AI plays a crucial role in the integration of renewable energy sources into the power grid. By predicting energy demand and renewable output, AI helps in balancing supply and demand more effectively. This is essential for increasing the share of renewables in our energy mix, as it addresses the variability and intermittency issues associated with sources like solar and wind. AI's impact extends beyond optimization and into the realm of forecasting and maintenance. Predictive algorithms can anticipate equipment failures and schedule maintenance, thereby increasing the lifespan and efficiency of renewable energy installations. This not only reduces costs, but also enhances the reliability and stability of green energy sources. Manufacturing, known for its hefty carbon footprint, can see a new dawn with the integration of AI. AI technologies enable more efficient use of materials and energy, reducing waste and emissions. For example, AI-driven robots can precisely cut materials, minimizing scraps in industries like automotive and electronics. This precision saves resources and reduces the waste that ends up in landfills. AI also revolutionizes the supply chain management within manufacturing. By predicting demand more accurately, AI reduces overproduction, a significant issue that contributes to environmental degradation. This not only ensures more sustainable production practices, but also aligns better with consumer needs, avoiding unnecessary manufacturing. Moreover, AI facilitates the adoption of circular economy principles. Through advanced sorting technologies, AI can help recycle materials more efficiently, ensuring that products at the end of their life cycle can be reused. This shift from a linear to a circular economy is vital for sustainable manufacturing practices. Section 4, AI in Agriculture, Cultivating Precision and Efficiency. In the realm of agriculture, AI is a game changer. Precision agriculture powered by AI allows for the meticulous application of water, fertilizers, and pesticides, which significantly reduces the environmental impact. Sensors and drones collect data that AI systems analyze to advise farmers on the optimal planting strategies and crop rotation, enhancing yield and soil health. AI also aids in managing crop health and pest control. By analyzing images from drones or satellites, AI can detect disease outbreaks or pest infestations early, enabling timely intervention. This not only saves crops, but also reduces the need for chemical inputs, promoting a more organic approach to farming. The implications of AI in agriculture extend to water management as well. AI systems can predict irrigation needs based on weather forecasts and soil moisture levels, optimizing water usage. This is crucial in regions facing water scarcity, ensuring that agriculture becomes more sustainable and less of a strain on local water resources. Section 5. Conclusion: AI's role in shaping a sustainable future. As we have explored, AI holds transformative potential across various sectors, driving sustainability forward. However, the deployment of AI must be handled with care to avoid potential pitfalls such as increased energy use by the AI systems themselves, or exacerbating social inequalities. The ethical implementation of AI is crucial to ensure that its benefits are realized on a global scale. The journey towards a sustainable future is complex and multifaceted. AI, with its ability to analyze vast amounts of data and learn from it, presents a powerful tool in this journey. By harnessing AI responsibly, we can enhance our ability to conserve resources, protect ecosystems, and build a more sustainable world. In conclusion, while AI is not a panacea, its intelligent application is undoubtedly a cornerstone of future sustainability efforts. It is an ally that, when ethically harnessed, can help us navigate the challenges of modern environmental stewardship.